Hi students, and welcome to the Chapter 8 lecture. Chapter 8 is all about vitamins. Chapter 9 is all about minerals and fluids. And we're going to be discussing these as a unit. Our micronutrients unit is essentially what we're entering into now. So vitamins and minerals, plus then also we'll talk about water, and we're also going to backtrack and talk about alcohol that we skipped over in Chapter 6. So that will be sort of all of the components of your next test. Chapters 8 and 9, and then we'll touch on alcohol. So it's a 2-chapter test, which makes it sound like it's going to be shorter or less material, but the vitamins and minerals chapters are actually quite long. There's a lot of vitamins and minerals out there, so this will probably be a longish lecture, which is probably going to be around 2 hours. We'll see how well that prediction comes out. And it's all about vitamins and the different vitamins in our diet. Okay, so vitamins, of course, are micronutrients, one of the micronutrients being vitamins and minerals, right? Vitamins are organic. That means they contain carbon. So it's different than when we talk about organic foods that are grown without the use of pesticides and hormones, etc. When we say that vitamins are organic, we're talking about organic chemistry, organic compounds. Just like the macronutrients are organic, meaning that they contain carbon and hydrogen. When we talk about minerals, those are not organic. They're simply elements off the periodic table. Vitamins are a little more complex than minerals, but much less complex than the macronutrients. Vitamins are essential for regulating body processes. In fact, the term vitamin actually was coined because it means vital, from vita-amine. Vital amines is what it was. So the person who first discovered the first vitamin, vitamin A, decided that these were important compounds that the body needs in order to function properly. So that's how all the vitamins are identified and classified. If a substance is necessary for the body to function properly, that is, if you don't get it, there's some kind of deficiency, then it's considered a vitamin. Most vitamins are essential. We need to get them from food. But there are a couple that we'll talk about that can be synthesized under certain circumstances. And vitamins are classified. We do group vitamins into 2 different groups. There's the fat-soluble vitamins, and then there's the water-soluble vitamins. Now, the fat-soluble vitamins are like lipids. They are not just soluble in water. So we absorb them along with our fats in our diet, and we transport them through the blood along with fats. And we can store them in the body along with fats as well. So fat-soluble vitamins are vitamins A, D, E, and K. You will need to know that. ADEC is my mnemonic. A, D, E, and K. So the good news about fat-soluble vitamins and the fact that we store them means that if you eat a little extra vitamin A on Monday, but then you don't eat enough on Tuesday, that's cool because whatever the excess vitamin A that you eat can be stored for later, so that if, a couple days later you don't eat enough, your body has vitamin A in storage. The bad news about that is that you can store excess levels if you eat or consume excess levels of the fat-soluble vitamins. They can accumulate to toxic levels in the body. So we do have to be careful about that. Now, the likelihood of reaching toxic levels, toxic dosages by eating food is very uncommon / near impossible to do by consuming food. The problem comes in when people take supplements, particularly if they take single vitamin supplements. So if you're taking, let's say, a vitamin D supplement, and it's a very high dosage, then you're taking it every day, a very high dosage every day, several days, for months at a time, you can accumulate toxic levels of vitamin D. So there's a term for that. It's called megadosing, taking 10 times the recommended dose of a vitamin. And vitamins A and D are the ones that are particularly dangerous, though it's coming out that vitamin E can be dangerous as well. The water-soluble vitamins are water-soluble, and we don't store them in large amounts. Because they're water-soluble, we excrete them with if there's extra water-soluble vitamins, we excrete them just like we excrete extra water through the urine. So that's good news. It means that it's nearly impossible to sort of overdose on them, and that very few of the water-soluble vitamins have toxicity effects. And if they do, they're pretty mild and temporary. But the bad news is that they need to be consumed more on a regular basis. If you go for long periods without consuming these vitamins, your body doesn't have any backup stores of them. So these include all the B vitamins. There's several B vitamins, and vitamin C. Those are the water-soluble vitamins. So like we said, vitamins are any type of compound that has a vital function in our body. And there's a lot of different types of functions that vitamins help with. Sorry, it's a windy day. Can't seem to close my window all the way. Vitamins, so the book classifies the vitamins as the ones that play important roles in all these different important functions in the body. I like this figure. So some vitamins play a really important role in bone health, maintaining bone health. Vitamins A, D, K, and C are all important for producing bones. We think of bones, we think of calcium, but calcium is a mineral, first of all, and second of all, it's not the only element that's important in maintaining our bones. In terms of energy metabolism, there are a lot of vitamins, namely a bunch of the B vitamins, that are important for helping us take those macronutrients, glucose, carbohydrates, fats, proteins, and breaking them down to make energy, to make ATP. We can't do that without the presence of several B vitamins. Amino acid metabolism, specifically breaking down our proteins, okay? And again, a lot of the B vitamins are important there. Antioxidant defense, we're going to talk about what that means, what antioxidants are, but essentially they help prevent your cells from being damaged by oxygen and other harmful chemicals. And they help prevent aging, cancer, etc. There are vitamins that are important for immune function, important for the immune cells to function. A lot of the vitamins are really important in forming blood. So there's several vitamin deficiencies that cause different blood disorders, either anemia or clotting disorders, due to their important function in our blood. And also for growth and development, just for proper growth and development. Vitamin A, we'll talk about, it's really important in development of the eye, for example. So back to that whole issue about antioxidants. What exactly is an antioxidant? So to understand what an antioxidant is, you have to understand a little bit about what oxidation is. So a lot of the biochemical reactions that occur in our cells, particularly ones that are involved in metabolism, involve transferring of electrons. Okay, that's just how a lot of chemistry takes place. Now, an oxidant is a chemical substance that removes electrons from atoms. And a lot of different substances can act as oxidants. The most common one is oxygen, acts as an oxidant. It removes electrons from other atoms. And we breathe oxygen all the time, every day. Other things, pollutants can be oxidants. UV radiation can be an oxidant. Okay? And what happens sometimes when things get oxidized is they form free radicals. All right, so what's a free radical? Here's my little cartoon depiction down here. So you have a molecule, it's happy, it's got its electron, it's got a pair of electrons, and it loses one of those because an oxidant comes and removes it. Okay, so then what you have left, this atom or molecule that's missing an electron, okay, is referred to as a free radical. A free radical. And what happens is this guy is now unhappy. He doesn't like that he's lost an electron, and he wants that electron back. So what's he going to do? He's going to go steal it from some other molecule. And now he's happy, but then now you've created another free radical, and it becomes this chain reaction, okay? An oxidant steals an electron, and it stimulates this chain reaction of free radical formation, okay? And free radicals can cause a lot of damage. That it damages cells when they become oxidized. So free radicals can go around stealing electrons from important molecules in your body that you need, and then they won't function properly. So the other sort of the analogy that your book uses is it compares free radicals to like arrows that cause damage, okay? And free radicals can damage your DNA, which is where your genetic material is, right? All of your genes are encoded there that encodes all your proteins. So if you have damage to your DNA, that can lead to cancer, can lead to an inability for the DNA to divide properly when cells are dividing, and that's what can lead to cancer. Cancer is sort of like the overproduction of cells. They keep dividing and dividing, and they don't know when to stop, and that can happen if your DNA is damaged. Another thing that can happen is so then that free radical can then go and damage phospholipids that are in your cell membranes, which can cause aging and signs of aging. So cells and tissues start to sort of fall apart because they're damaged. But also it can damage the phospholipids and the proteins in those lipoproteins, the LDL particles, the bad cholesterol, and that can cause them to rupture and or stick to the inflamed cellular lining of your blood vessels, leading to plaque buildup, leading to heart disease. Okay, so aging, heart disease, and cancer, all in part can be, I don't want to say can be caused by free radicals, but free radicals can play a role in the formation of all of these diseases. So what is an antioxidant? An antioxidant is, like in this analogy that the book uses, like a shield. It's a molecule that absorbs, it basically neutralizes free radicals. It stabilizes them without becoming one. So a lot of these free radicals, it's a chain reaction. Remember, that's what this thing is showing here. The DNA gets attacked by a free radical, then becomes a free radical itself and goes and attacks the phospholipid. Then the phospholipid becomes a free radical and goes and attacks this protein. Okay, so that chain reaction. Normally when a molecule is, attacked by a free radical, it becomes one itself, but an antioxidant does not. It can bind to free radicals and it can neutralize them and keep them from continuing this chain reaction. It puts a stop to it, and it protects all these molecules in our body. So there's a lot of antioxidant nutrients, and a lot of them are vitamins and are very important for protecting our tissues, protecting the molecules in our cells. The important antioxidants you should know, and we'll come back to them when we discuss them individually, but these for the vitamin E and vitamin C are the two major antioxidants in the body. Vitamin A, particularly the version that's called beta-carotene, is an important antioxidant. And also several of those phytochemicals we talked about in Chapter 1 are all antioxidants. Okay, they help prevent a lot of diseases that are associated with oxidative damage. So before we start talking about each of the individual vitamins, we're going to talk in generalities about vitamins. So there's different sources for vitamins in our diet. One, the most sort of basic one, is in food. Eating food that has vitamins in it. So pretty much all food contains all food that's not heavily processed contains vitamins. So whether it be plant source, animal source, fungi, bacteria, all of those supply natural vitamins in our diet. You can also get vitamins from supplements, particularly multivitamins are the ones that are recommended because they usually have 100% of your daily value for several different vitamins, so they don't put you at risk of mega dosing. They're not super large doses. They're just give you your daily needs. So One A Day is a popular brand. Something to note about supplements, a lot of vitamins and minerals in supplement form are slightly different molecularly or chemically than the vitamins that you find in food. So off the top of my head, an example, in food, there's a B vitamin called folate that naturally occurs in food. And it's really sort of a family of molecules. There's another form of folate called folic acid, and that form happens to be more absorbable. So that's the form that's often found in supplements. So in that case, the supplement actually is more absorbable, but in some cases, the vitamins in supplements are not as absorbable, or they have different biological activity than the natural form. So it's not quite the same. Taking a supplement versus getting your vitamins from food is not necessarily the same deal. The other way to get vitamins and minerals in your diet is by eating or drinking fortified foods and drinks. That means that they are foods that have some natural vitamins, but then they've also had supplements sort of added in. So two pretty sort of popular examples or good examples here are cereals. Pretty much all cereal, except I think like Kashi brand and maybe some other like organic brands, are not supplemented. But pretty much your popular cereal brands are all fortified. That's why they have this long list, nutrition facts panel, long list of vitamins, because they are supplemented sort of in the cereal. Also, vitamin water, which came out a few years ago, is a drink that's supplemented with vitamins. So we call these foods fortified foods. They've been fortified with vitamins and minerals. When it comes to vitamin absorption, we don't absorb vitamins necessarily as well as we absorb our macronutrients pretty darn well. The only one we really don't break down and absorb is fiber. But a lot of the other carbohydrates we break down and we absorb them. Vitamin absorption is not that great. It's not 100%. It's usually far less than 100%. So, there may be 100 milligrams of calcium in a serving of spinach, but we only absorb maybe 30% of that, okay? So that's something that is taken into consideration when they calculate the percent daily values. So when you look at a bag of spinach and it says that it provides only 30% of your daily needs of calcium, it's because even though there's actually a lot of calcium in spinach, you can't absorb it all. Your body can't absorb it all. Then that's a mineral example, not a vitamin example. But this story is true for both vitamins and minerals. So vitamin absorption is something that can be enhanced or inhibited depending on other factors that are in your diet, or diseases or conditions that you have. So when it comes to fat-soluble vitamins, having some fat in your meal helps you to actually absorb fat-soluble vitamins. So one classic example is tomatoes with olive oil. If you eat a tomato plain by itself, okay, that's great. You'll absorb some vitamins. If you eat it with a little bit of olive oil or some salad dressing that's fatty, you'll actually absorb more of those fat-soluble nutrients. Another one that I like to highlight is milk. Milk is fortified with vitamins A and D, which are both fat-soluble vitamins. If you drink fat-free milk and there's no other fat in your meal, then you are not going to absorb as much vitamin A and D from fat-free milk as you would from 1%, 2%, or whole milk. So having a little fat in your meal is good to enhance absorption of fat-soluble vitamins. Also, fiber can inhibit some absorption. Fiber inhibits absorption in good ways, sometimes by slowing down sugar absorption and by reducing fat absorption, but it also can inhibit vitamin absorption, can sort of bind up the vitamins. Some conditions that can enhance or inhibit vitamin absorption: certain periods of time where your body needs more vitamins cause your body to basically become more efficient at absorbing them. So periods of growth during adolescence and childhood, pregnancy, etc., all actually enhance your absorption of a lot of vitamins and minerals. You get more absorption than you normally do. If you have a condition that causes you to have inflammation in your intestines, okay, if your intestinal cells are all red and inflamed and angry, they're not going to be absorbing any nutrients as well, including vitamins. Also, as you get older, you stop producing, or you produce less stomach acid and less, other factors that we're going to talk about that enhance vitamin absorption. So as you get older, your intestines tend to absorb things less efficiently. So those are some different things that can change your body's ability to absorb vitamins and minerals. Vitamins are important for our bodily functions, so not getting enough of them causes deficiency diseases. And some of them, particularly the fat-soluble vitamins, if you take too much, can cause toxicity, can have toxic effects on the body. So a little bit generally about deficiency and toxicity of vitamins. Deficiency diseases are pretty uncommon in the U.S. because we have first of all, we have a lot of fortified foods. A lot of the foods that are food staples, including bread, are fortified with vitamins and minerals, so that helps. And the reason they're fortified is to help prevent deficiency in a public health sort of way. That's not to say that no one ever has vitamin deficiencies or deficiency disease, but it's fairly rare. It's not like a major public health problem anymore. There are certain populations that are much more at risk for vitamin deficiency disease, either due to their eating habits or due to lack of eating or due to lack of ability to absorb. So alcoholics, for multiple reasons. One, the alcohol consumption can block absorption, but also a lot of times when people are chronic alcoholics, they're not eating properly or eating at all. They substitute food for alcohol. Elderly people lose their appetite as they get older. They don't have any taste, they have their taste buds there's fewer taste buds, they have less taste, less appetite, and less ability to absorb vitamins. People with eating disorders, again, because they're not eating or they're vomiting or getting rid of the food that they're eating. Any intestinal conditions that cause inflammation and poor absorption, or metabolic defects that cause them not to be able to make essential nutrients or something like that. So there are still deficiency diseases, but they're fairly rare and usually amongst these particular populations. Vitamin toxicity is very rare from food. We'll talk about like one or two examples of when you can there's certain foods that you can accumulate toxic levels of vitamins. But most cases of vitamin toxicity are from taking vitamin supplements, particularly the single vitamin supplement. So not from taking a multivitamin, but from taking a vitamin A supplement, for example. Okay. When it comes to vitamins in food, some of them are destructible. So cooking, the way that you prepare food, you might want to take into consideration the way you prepare food when you're thinking about trying to get the maximum amount of vitamins out of your food. So there are some vitamins that are destroyed by heat. A lot of them are. So I have a slide. The next slide kind of goes through the different vitamins and what they are sensitive, what sort of conditions they are sensitive to. And but a lot of them are sensitive to heat, so heating them destroys them. So the best method when you're preparing foods is to use some kind of quick cooking method. So either steaming or microwaving or stir frying, as opposed to deep frying, which is a long time in very high heat oil. Or even baking. Baking can destroy it too. Now, the heat does not necessarily, if you bake your potato, it's not going to destroy all the vitamins in the potato. It'll destroy some fraction of them, right? So the quicker you cook it, the less time it spends in heat, the more vitamins you'll actually preserve in the food. There's a little caveat to that, which is that there are some phytochemicals that have been shown to actually be released by cooking, because cooking denatures proteins, and sometimes vitamins and minerals can be kind of embedded in proteins or sort of blocked by proteins, so denaturing the proteins actually can release some of the vitamins and minerals. So it's not always a bad thing to cook, but when cooking, try to spend as little time in heat as possible. Try not to overcook is what we're saying. Some vitamins will actually degrade during food storage, so it's better to eat your produce fresh. It's better to eat food fresh. The fresher it is, the more vitamins and minerals it's going to have. And also, it also means that frozen foods, frozen produce, are better than canned produce, because frozen, when you freeze something, you sort of freeze the degradation too. Like, things don't get broken down, bacteria don't grow, and most frozen vegetables and fruits are frozen when they are ripe and fresh. So they're freshly picked and ripe and then immediately frozen. So it preserves a lot of the vitamins. Whereas when you can vegetables, there's a lot of processing that goes into it, and then they sit usually in some kind of juice in a can at room temperature, and a lot of the vitamins can actually degrade over time. So try to eat foods fresh. And then lastly, boiling foods can leach out water-soluble vitamins. So, and same thing with fat. Boiling in oil or deep frying foods can actually leach out fat-soluble vitamins, while boiling in water can leach out water-soluble vitamins into the water. So if you have a vegetable like green beans or something that you want to boil, try to minimize the amount of time that they spend in water, or stir fry them or microwave them, or do something where you don't actually have to boil them. Steaming is a great way, a great alternative to boiling, and it helps preserve those water-soluble vitamins. Otherwise, if you can, if you boil vegetables in water, if you can use that water for your, like, so let's say you're making a soup, okay? Boiling the vegetables in the soup broth is fine. It'll leach out the vitamins, but then they'll be in the broth. So it's only bad if you're actually draining the fluid, the boiled water, then you're throwing out fats or the water-soluble vitamins. So here's a chart showing the different vitamin stabilities. Okay, so vitamins can be sensitive to light, to oxidizing agents like oxygen in the air, to heat, etc., is what we were talking about. So you can go down this chart if you're curious about certain vitamins. Notice a lot of the fat-soluble vitamins here, A, D, E, and K, are the fat-soluble ones, are sensitive to light. Things like A and D are found fortified in milk, and milk, you'll notice, comes in these sort of dark, opaque containers, okay? A part of that is to try to protect those vitamins from breaking down in the light. Thiamine, one of the B vitamins, very sensitive to heating. And the fat-soluble vitamins as well are slightly sensitive to heating. So if you cook something that has vitamin A in it, it'll lose some of its vitamin A, but not all of it. Vitamin C as well. When you cook things like peppers are actually a great source of vitamin C. You cook them, you destroy some of the vitamin C, but not all of it. Okay, so those are some of the generalities about vitamins. Now for going into the specific vitamins. So the fat-soluble vitamins we said are vitamins A, D, E, and K. There's 4 of them. And the first one we're going to talk about is vitamin A, which is also called retinol. Okay, it's important in the eye, in the retina of the eye, but it has a lot of other important properties as well. But it's a family of compounds that are called retinoids. Okay, so there's actually more than one. There's vitamin A, which is found in animal products and meat sources. And then there's the carotenoids, which are actually plant pigments that are orange or red in color. And they are very similar, and your body actually converts them both to the same thing. So the carotenoids, particularly the one that is similar to vitamin A, is called beta-carotene. Okay, so retinol is vitamin A. Beta-carotene is also vitamin A, a source of vitamin A. So here's retinol, the molecule retinol that we use in our bodies. And here's a molecule of beta-carotene, which essentially can get clipped and can be turned into retinol here. And both of these molecules, both beta-carotene and retinol, can be converted to this molecule called retinal. Retinol versus retinal. And retinal is the compound that's very important in the retina of the eye, as you'll see on the next slide. Okay, so here's a picture of your eye. Light goes in through the pupil, really, and hits the back of the eye. The back of the eye is lined with this tissue called the retina. And that is where the image is formed in your eye, and that is where the image gets sent via nerve signals back to the brain to form an image. Okay, so the retina is pretty important in terms of the function of the eye. And that retinal molecule is essentially what allows us to recognize light and convert it to an image. Your book has like a whole diagram showing you, molecularly how retinal functions. You don't need to know that level of detail. All you need to know is that retinal is important for the eye to be able to form an image, as to process light and convert it to an image. But you're welcome to read that section of the book if you'd like to know more about that mechanism. So, that being said, one of the early signs of vitamin A deficiency is night blindness, an inability to see well in low light because of a lack of retinal. Okay. Now, retinol, vitamin A, can also be converted to retinoic acid. So retinol can be converted to retinal, but retinol can also be converted to retinoic acid. And retinoic acid is important for a lot of different development functions. So the cell differentiation of cells into different cell types, which is how they sort of grow and specialize to their different functions. So it's important for skin cells, it's important for blood cells, for sperm cells, the immune system, all critical functions of vitamin A in the form of retinoic acid. So here's just a reminder that retinol is vitamin A that comes from animal sources. So we've got meat, cheese, eggs here. And then you also have your carotenoids, your beta-carotene, which can be converted to retinol and then converted to retinoic acid. So speaking of sources of vitamin A, this is a nice table from your book which lists them. So notice here that there's one source of vitamin A that is extremely high, and that is in liver. So on the chart here it's showing beef liver, but any animal liver, chicken liver, beef liver, I don't know, people eat pig liver, but any type of liver is very, very high. So it's telling you here that the RDA for men and women is 700 to 900 respectively. whereas beef liver has 6,500 milligrams. Okay, that's almost a megadose for a woman. 1 3-ounce serving of liver is almost 10 times as much as she should have. So liver and vitamin A is a fat-soluble vitamin that we're going to talk about, is toxic at high doses. So liver is one of the sources, is really the only food source that you could potentially have toxicity of vitamin A. So liver, I like chopped liver, but I would not eat it on a daily basis for this reason. Well, for lots of reasons. But so notice here, so you've got, this is an animal organ meat. Are there any other animals on here? Not so much. There's eggs and some fish here. Most of these you'll see are orangey red colored vegetables, or that they're green leafy vegetables. Those are the ones that are very rich in beta carotene. So the rule, I guess, of thumb is if it's orange or dark green, it's going to be a rich source of beta carotene, which is a form of vitamin A. Okay. When it comes to vitamin A adequacy, there is such a thing as too much vitamin A. Now, vitamin A in the retinol form is highly toxic, okay, particularly from supplements, because a lot of food sources, again, don't have enough vitamin A. The exception there is liver. You can overdose on vitamin A by eating too much liver. So that's the only food to really watch out for. And it can cause birth defects, so pregnant women are actually told to really kind of stay away from liver. It can cause damage to your liver. Too much vitamin A can. And also can cause damage to the eye, too much retinol, I suppose. Beta carotene, however, is not toxic in excess amounts, because I guess your body regulates what it converts it into. But excess beta carotene will not cause any kind of pathological toxicity, but it is fat soluble and it can get stored in your fatty tissues. And it's orange colored. It's a pigment. So if you eat excess beta carotene, you can actually turn orange. No joke. It's a condition called carotenodermia. Okay, so condition of orange skin. And this is a picture of two people, one person like normal colored hand and another person who eats a lot of carrots and actually has orange tinted hands, carotenodermia. And this is actually common in babies, usually around their nose. Their nose turns orange and their hands. If you give them a lot of carrot juice, or they like carrots, like baby food carrots. But I even had a friend in high school who she loved carrots, and she ate carrots for lunch every day. I guess she just ate a lot of carrots, and it was mostly her hands. Like, it wasn't so much necessarily her whole body, but you could tell her hands were more orange than the person next to her. So it's temporary. If you stop eating, if you cut down on your beta carotene consumption, the orange goes away. Oopsie. Vitamin A deficiency is not a huge problem in the U.S., but it is actually a very big problem globally. It can cause, initially it causes night blindness, but can cause total blindness if it goes on, if it's severe enough and chronic enough. And it is a major cause of blindness in underdeveloped countries where they don't have a lot of vitamin A in their food staples. Also, because of its important role in cell development in the blood and immune system, it can cause reduced immunity, it can cause reduced fertility. So those are some of the signs or symptoms of vitamin A deficiency. The next fat-soluble vitamin is vitamin D. And technically, vitamin D is a hormone. When it was discovered, it was not known that the body actually can synthesize vitamin D. So the body synthesizes vitamin D in the skin upon exposure to sunlight. So sun hits the skin, and the skin forms this pro-vitamin D that then goes to the liver and kidneys and gets further processed to become active vitamin D. Okay, so it's a cholesterol-like molecule in your skin that gets activated by the sun to produce vitamin D. And vitamin D has a couple of critical functions in the body. These are the three major functions of vitamin D. One, it helps you, I'm going to say one down here. First of all, it helps you actually absorb calcium and phosphorus from your diet, from the intestines. So without vitamin D, you don't absorb enough calcium and phosphorus. It helps to regulate the levels of calcium in your blood, and it also helps to regulate the calcification or the hardening of the calcium in your bone. So vitamin D is very important for the bones because it helps, sort of works hand in hand with calcium. It enhances the absorption and it enhances the mineralization of calcium. Now, because it's produced in the skin by sunshine, it's often referred to as the sunshine vitamin. And it takes a certain amount of UV radiation hitting the skin in order to initiate this vitamin D synthesis. So if you live in regions where it's not particularly sunny, or it's a certain time of year where it's not particularly sunny, you don't actually produce a whole lot of vitamin D on your own, and you become more dependent on getting it from your diet. So there's a line, the 37th parallel, that is considered, that this, I'm showing it across the United States, but it goes, of course, across the whole globe, that above that line in the northern hemisphere, there's not enough sunlight year-round in order for you to make enough vitamin D. So you do have to get vitamin D from the diet, particularly in the winter months. And we are somewhere up here in the North Country, so we are definitely well above that line. We definitely need to work on getting our vitamin D from other sources besides the sun. There's maybe a couple months, maybe 3 months in the summer where we can get good source of vitamin D from the sun. Because of its role, because of vitamin D production in the sun, there have been a lot of implications, a lot of research suggesting that vitamin D may actually play a role in seasonal depression, which is depression during the winter, essentially, and that maybe it's actually from having low vitamin D levels. Could be. It's a valid hypothesis. The other thing to note is that sunscreen, so that vitamin D is synthesized because of the UV that hits your skin and stimulates that cholesterol-like molecule to turn into vitamin D. If you are protecting your skin from UV, if you're covered up, whether it be with clothes or with sunscreen, then you actually are blocking that UV absorption, and you block UV or vitamin D production. So actually some nutritionists and dermatologists alike will actually recommend now that instead of putting on sunscreen before you go out in the sun, wait about 10 minutes before putting sunscreen on so that you can get that vitamin D production, and then you get the UV protection. It really doesn't take very much vitamin D or much UV exposure to produce enough vitamin D. Your body, I think the numbers are something like 10 to 15 minutes, 2 or 3 times a week is sufficient to produce enough vitamin D for your recommendations. So if you're totally covered head to toe in high SPF sunblock all summer, you're also not making much vitamin D. So there's also food sources of vitamin D. These couple of slides show you some different food sources. There aren't that many food sources is the issue. Fish is a good source of vitamin D. Eggs and milk have a decent amount, and then also fortified foods like fortified cereal is a decent source of vitamin D. So I make little art mnemonics. Okay, so my little art mnemonic for vitamin D here is that it's a can of tuna fish, so fit or salmon, both have vitamin D, and then it's a sun. It looks like a sun because vitamin D also comes from the sun, and the eyes and the mouth are all D, the letter D, to remind you that vitamin D comes from fatty fish and from the sun. But there's also some other sources for it as well. So here's the list from your book showing you sort of the chart. And the RDA, the recommended dietary allowance for vitamin D, is assuming that your sun exposure is inadequate. So if you live in Florida, you don't need to eat 15 to 20 you don't need 15 to 20 micrograms of vitamin D a day. You probably don't need any from your food if you live in Florida and you spend a little time outside every day. But in the middle of winter in the North Country, you do need to get vitamin D from your food sources. So how much is what happens if you get too much? What happens if you get too little vitamin D? Too much vitamin D, again, not likely from food, but is possibility from taking supplements. And essentially it results in high blood calcium levels, which can have detrimental consequences in terms of muscle contraction and also in your bones. So you don't want to have too much vitamin D. Having way lot of vitamin D actually can be life-threatening. Vitamin D deficiency causes deformities of the bones. So depending on what stage in your life cycle you are, it causes sort of different consequences. So early in life, when the bones are still growing and still forming, if you don't get enough vitamin D, you get these soft bones that don't form properly and they start to bend, particularly the large weight-bearing bones in your legs. And this disease is called rickets, and it used to be a really big problem in the United States in the early 1900s, late 1800s, turn of the century. Also was, I think, around the Industrial Revolution. And in big cities where there was a lot of smog from industry, and so the smog actually blocked out the UV radiation, so people weren't getting that UV, the vitamin D that they needed from UV, from the sunlight, and then they also weren't getting it from foods. A lot of people were coming down with rickets, and so a doctor ended up figuring out that fish oil actually cured rickets or prevented rickets. And so they didn't know that it was vitamin D yet, but they later figured out that it was the vitamin D in the cod liver oil. That's what it was, cod liver oil, that helped treat the rickets. As you get older, your bones are formed already, but if you don't get enough vitamin D, you don't have enough sort of maintenance of your bones, which can cause a softening of the bones called osteomalacia, and that's the form of vitamin D deficiency in adults. Osteomalacia is more reversible than osteoporosis, so if you start getting enough vitamin D, you can usually reverse that bone softening and re-harden the bones. So that's the good news. There's also a lot of research suggesting that vitamin D deficiency plays a role in a number of different disorders. We already mentioned seasonal affective disorder. It might cause an increased risk for certain types of cancer, for type 1 diabetes, for tuberculosis, actually. In fact, Saranac Lake the town Saranac Lake was built as a tuberculosis treatment center by E.L. Trudeau, Edward Livingston Trudeau, and a lot of people came here to treat tuberculosis by sitting out on their porches and breathing in the fresh air and getting sunlight. And there is some research that actually suggests vitamin D may play a role in the body's ability to fight off tuberculosis. The next fat-soluble vitamin is vitamin E, also known as alpha-tocopherol. And vitamin E is an important antioxidant. I mentioned that it was the first of the antioxidant minerals we'll talk about, or vitamins. So it protects our cells from free radical damage as an antioxidant. It helps protect our cell membranes. It helps protect LDL particles, the bad cholesterol. It protects our red blood cells, and it protects cells surrounding the lungs. So all of these cells are really guarded by vitamin E. And vitamin E also plays a critical role in the development of muscles and nerve tissue. So there's various sources of vitamin E in our diet. In vegetable oils, it's fat soluble, so it's in a lot of fatty kind of places. Vegetable oils, nuts, seeds, soybeans, all of those are like oily types of plant sources. Wheat germ, and you can also find it in fortified cereals. So vitamin E happens to be very sensitive to destruction by a number of different sources: oxygen, sunlight, heat. So eating foods as fresh as possible is the best way to get the most vitamin E out of them. Too much vitamin E is not common at all. It's really only caused by taking too many dietary supplements. But there's not a huge market for vitamin E supplementation, so it isn't a huge problem. But it can be dangerous, particularly because of the role that vitamin E plays in blood clotting. So vitamin E deficiency usually causes anemia because, remember, vitamin E helps protect or guard red blood cells from oxidation. If they get oxidized, so free radicals start attacking the red blood cell, it bursts open, it lyses, and you have fewer red blood cells, which is the definition of anemia. So if you have too much vitamin E, well, I guess it doesn't really mean they're sort of different, but vitamin E can interfere with blood clotting is the issue. So too much vitamin E can cause dangerous hemorrhaging or a risk of hemorrhaging. And something interesting about vitamin E deficiency, it's very rare in America, even though most people don't consume the recommended amount. So if you look, I bet 90% of you, if you look at your diet analysis report and you look at your vitamin E consumption, it's probably pretty low. Every semester that I do this assignment, in the past I've actually tallied up the class's results, and people, the class average is like 20 or 30% of their daily recommended intake of vitamin E. Yet vitamin E deficiency is very, very rare. So it kind of makes you question whether the RDA is too high. Maybe the RDA is or the AI is higher and maybe could be lowered. Maybe we could get by with actually a lot less vitamin E than nutritionists once thought. Vitamin K is the fourth and last of the fat-soluble vitamins. The K stands for coagulation, spelled in the Dutch spelling of coagulation, because vitamin K is important for blood clotting. So all the other vitamins I should mention are named A, B, C. They're named in order of their discovery. So vitamin A was first, then vitamin B1 thiamine was the second vitamin discovered, then vitamin C, then vitamin D, then vitamin E. And then there were a whole bunch of B vitamins that were discovered, and they were all very similar in function, so they were all grouped together as the B vitamins. Vitamin K is the only one that's named after its function. So there's a little bit of trivia for you there. So vitamin K, but it helps you, it's nice because it actually helps you remember what the vitamin does. So K for clotting, okay? K for coagulation or clotting. And essentially, vitamin K is, so when your blood clots, there's different clotting factors that are involved. You have platelets, which are the sort of clotting cells. And then you have 9 different clotting factors, which are different proteins. And all these proteins and platelets stick together and aggregate and bind to red blood cells and cause the blood to clot. So vitamin K is really important in order to be able to make a lot of those different clotting factors or clotting proteins. And its secondary function is in bone health, so vitamin K also plays a role in bone health. There's different sources for vitamin K, so vitamin K is actually sort of more of a family. There's a couple of different types of vitamin K, and for this class we're just going to simplify it and say there's two types, vitamin K1 and vitamin K2, known as the phyloquinones and the menaquinones. I'm not going to test you on that, but your book does talk about it, and they're in italics, so throwing them in here for you and for your information. So the phytoquinones, vitamin K1, are found in green leafy vegetables is the main source of that type of vitamin. So any type of green leafy food. So here's my little artwork here of a K made out of green leafy vegetables to remind you that they're good sources of vitamin K. The second type of vitamin K, vitamin K2, the menaquinones, come from different protein sources, of different animal sources. Okay, so meat, fish, dairy, poultry. Sorry, poultry is chicken, yeah. But also they come from bacteria, particularly the bacteria in your intestines. So the bacteria in your stomach actually produce a fair amount of vitamin K that you can then absorb and use for yourself. So it's kind of nice of them. We can benefit from that. But they don't quite produce enough for you to just get by on that, so you do have to get it from food a little bit. But again, vitamin K deficiency, not really a big issue in the United States. We get it, you have it from your intestinal bacteria, and B, it's in a lot of different foods. It's in animal foods as well as plant foods, so it's not difficult to get the necessary amounts. Although vitamin K is a fat-soluble vitamin, there are no known effects of getting too much vitamin K, and I don't think people take it as a supplement ever, except for in this one instance, which is newborns. So newborns are born with sterile intestines. They don't have any bacteria colonizing their intestinal tract until they start breastfeeding, until they start feeding out in the open world. But in utero, there are no bacteria there. So they come out and they have very low levels of vitamin K. And breast milk has pretty low levels of vitamin K. So it makes them a little more prone to bleeding because their blood doesn't clot as well. And the issue with that is that it's rare, but there are instances of fatal hemorrhaging in babies, particularly intracranial hemorrhaging from the trauma of coming out, of having their head squished through the birth canal. It can, in very rare cases, cause intracranial hemorrhaging in the head and the brain. And vitamin K, if you give the babies a shot of vitamin K, it reduces the risk of that intracranial hemorrhaging. So it's standard procedure to actually give newborn infants a single dose injection of vitamin K to get them started in life with their vitamin K levels. Other cases of deficiency of vitamin K, people who have liver disease or diseases that impair fat absorption, so they're not absorbing vitamin K properly or processing it properly. And in those cases, vitamin K deficiency causes, because it's important for blood clotting, if you don't have enough vitamin K, your blood doesn't clot properly, so it causes excessive bleeding or potential bleeding disorders. Also, for people who are on blood thinners, like for heart disease, a lot of times they're told to avoid food sources that are high in vitamin K because it thickens the blood, it increases the blood's ability to clot. So a lot of times they're especially told not to take any vitamin K supplements. But vitamin K can interfere with blood thinners. So those are all the fat-soluble vitamins. Now for the water-soluble vitamins. Those are, remember, vitamins C and all of the B vitamins. And they are not stored in our body. They are excreted if we have them in excess. So you'll see that there's very few toxicity symptoms with them. So the first thing we're going to talk about are the B vitamins. And the B vitamins are a family of different vitamins that all are very important for energy metabolism. So taking our glucose, our lipids, our amino acids sometimes, and breaking them down to make ATP. That's what essentially, when metabolism is really the sum of all the chemical processes that go on in cells in order for them to sort of function. But when we talk about metabolism in nutrition, we're often referring to the production of ATP, of energy. And B vitamins are very important for that. So the reason they're important, like how it is that they function, is they act as coenzymes. So in order to break down glucose and turn it into ATP, it's like a 10-step process. It's a 10-step chemical reaction that uses multiple enzymes in order to convert that glucose into ATP. So there are a number of enzymes involved, and a lot of enzymes in the body, they can't just function. They don't just run around. They're not on all the time. If they were on all the time, that might be wasteful. It might be harmful, because if there's not glucose around all the time, you don't need these enzymes to be around all the time. Just like if you're not home, you don't need to leave your lights on. It's just wasteful. It's wasting energy. And the body doesn't like to, it likes to be energy efficient. So enzymes, we have internal ways to turn enzymes on and off. And one of them is by requiring them to have a second, sort of like a key that kind of turns them on, called a coenzyme. And a lot of the B vitamins function as coenzymes. So you have an enzyme, you have the chemical compound it's going to digest or, process. Okay, so like let's say this is sucrase, and this is sucrose or something like that. And the sucrose binds to the sucrase, but it won't work. The enzyme doesn't work because it needs this coenzyme to be bound to it. So a B vitamin will come in and activate that enzyme and turn it on, so that then when that chemical compound does bind, then the reaction can take place and the enzyme can do its thing. But it can't do its thing without its coenzyme. It's like a superhero and his sidekick or something. Okay? So there's a long list, of B vitamins. And this is the list. So thiamine, riboflavin, niacin, pantothenic acid, vitamin B6, folate, and vitamin B12. So in parentheses, I have what number B vitamin they are, but we really don't refer to them ever as B1, B2, B3. It's always thiamine, riboflavin, and niacin are the common names. Okay? So thiamine is a coenzyme, of course. It's required for carbohydrate metabolism and for some of the amino acids. And it's found mostly in grains, particularly in enriched grains and whole grains. You can also find it in pork. Thiamine is a rich source of pork, or pork is a rich source of thiamine. And if you don't have enough thiamine, the thiamine deficiency disease is called beriberi. And there's different forms of beriberi. There's wet beriberi and dry beriberi. They have different symptoms, but essentially the symptoms all revolve around nerve damage and muscle wasting. So it's not pretty. It's very it's a very uncomfortable disease condition. And some populations in which actually beriberi is very common. One is in alcoholics, because alcohol can actually reduce the absorption of thiamine, and then also alcoholics oftentimes forego food for alcohol. And they are the type of thiamine deficiency that they get. It results in muscle wasting and nerve damage, but it sort of has special symptoms. So there's a lot of confusion and memory loss involved, and disorientation, and sometimes funny eye movements. And it's called Wernicke-Korsakoff syndrome. So it's sort of a special syndrome caused by thiamine deficiency in alcoholics. Another source of thiamine deficiency is in populations that eat a lot of rice. That rice is their main staple, their main grain, because rice is notoriously low in thiamine. So people who eat, so in a lot of Asian populations, beriberi is much more common in Asia than it is in the U.S., for example, because they really depend on rice as a main staple. Brown rice, however, does have thiamine. Riboflavin is the second B vitamin. It's also a coenzyme. It's required for carbohydrate and fat metabolism. And it also happens to act as an antioxidant. So flavins are actually yellow pigments. So riboflavin is yellow in color. And you find it in milk. Again, it's very light sensitive. So it's another reason why milk is stored in opaque containers. It helps to preserve the riboflavin, as well as vitamins A and D, which are light sensitive as well. Egg yolks are actually a yellow color because of the flavins in the yolk. So a nice yellow yolk is a rich source of riboflavin. And any enriched grains, you're going to see pretty much all the nutrients, but particularly the B vitamins. Enriched grains and cereals are a good source for a lot of vitamins and minerals because they're fortified, essentially. So I almost don't think they count because they're fortified, but liver is also a good source of riboflavin. Riboflavin deficiency is very rare, so I'm not even really going to talk about symptoms or anything. Niacin is another B vitamin. It's a coenzyme that helps with the metabolism of carbs and fats. And there's a few sources of niacin, aside from the fortified foods like enriched flour and cereals. You can get it from meats. Meat, fish, and poultry are good sources of niacin. Corn, there's this special story about corn and niacin. So corn, niacin was really a big problem in the U.S. Niacin deficiency, which caused a disease called pellagra, which is on the next slide, was a big problem in people who had corn-based diets. Because corn, although it does have niacin in it, it's not bioavailable. It means that we can't absorb it. It's sort of trapped in proteins in the food that we don't digest very well. So if you eat corn on the cob, you don't get very much niacin from that at all. So people who ate even corn flour, like milled corn, still, it was all low in niacin. Those diets were low in niacin, so it caused niacin deficiency. However, there are other populations, particularly Mexicans. In Mexico, corn is a major staple of their diet, but they didn't suffer from these niacin deficiency diseases ever. It's because the way they prepare the corn, before preparing like corn tortillas, they actually soak the corn in lime water, and that lime water is basic. The pH of it actually helps to denature those proteins that trap in the niacin, so it actually releases niacin that then is present in the food that they eat. So it's kind of interesting how food preparation can actually affect the nutrient quality of the food. So deficiency, I said, causes a disease called pellagra, which causes this very stereotypical, like, characteristic rash. So you get breakout in a rash is one thing that happens. But also you can have diarrhea and different types of nerve damage, mental impairment, as a result of pellagra or niacin deficiency. Niacin toxicity is, again, mostly from supplements, not from food, and it can cause damage. The sort of the basic side effect is that it causes facial flushing. So it's a temporary side effect, causes basically your face to heat up. You feel kind of hot, maybe sweaty for a minute. But if you really overdo it from supplements, it can cause liver damage. So I have 5-Hour Energy on here because 5-Hour Energy drinks are basically a mixture of caffeine and a bunch of B vitamins, and in some cases, very high doses of B vitamins. And one of the B vitamins that's in 5-Hour Energy drinks is niacin. And there's actually a warning on the label, or this, I got this from the website, but I'm pretty sure it says it somewhere on the label about flushing. It says that some people are sensitive to niacin and may experience a niacin flush, a hot, prickly feeling, skin redness that lasts a few minutes. This is caused by niacin increasing blood flow near the skin, and it can be avoided by taking half a bottle or less at a time. So, B vitamin supplements, same thing if you're taking B vitamin supplements. And at the end of the lecture, we're going to talk about vitamins as medicine. And niacin, actually large doses of niacin can be used to control blood cholesterol levels. And this flushing, again, is a symptom of that, of taking large doses for medical purposes as well. Vitamin B6 is, again, a coenzyme. Happens to be a coenzyme that's very important for protein breakdown, for protein metabolism. It helps break down the toxic amino acid homocysteine that we said increases your risk for heart disease. It helps to synthesize hemoglobin, which is a protein that we talked about that carries oxygen in the blood. And it helps to synthesize a lot of protein neurotransmitters. So it's kind of the protein vitamin B6 is. And we actually get it from a lot of protein sources. So it makes sense that it would play a role in breaking down proteins and processing proteins. And we get it from foods that are high in protein. Animal foods, liver, fish, poultry. It's also found in starchy vegetables like legumes. And, of course, in fortified cereals. So, vitamin B6 adequacy. You can get some toxicity of this one. Most of the B vitamins, like niacin, there can be liver damage from too much, but not really. But otherwise, it's facial flushing is the only sort of side effect, which is just more annoying than it is dangerous. Riboflavin, there is no toxicity of riboflavin. There's no toxicity for thiamine. So a lot of the B vitamins, there's no toxicity for taking in too much of them because they're water soluble. We just excrete what's extra. Vitamin B6 is one where there are some toxic effects. So taking too much vitamin B6 can result in nerve damage, and it can result in different skin lesions. So that's one that you want to watch out for. So that's another reason why I like to pull in this 5-hour energy thing, because a lot of people take it, a lot of students take it, and maybe having 1 or 2 in a day is not so bad, but you really have to regulate, because look at the nutrition facts on the back. There's a lot of B vitamins, including niacin and B6, which can be toxic in high doses. So you want to make sure that you know what the upper limit is for these vitamins. And it's not mentioned in this chapter, but if you remember from chapter 1, we talked about safe ranges, and or was it whatever chapter we're talking about the different DRIs. Okay, there's upper limits for the vitamins listed in a table in the back of your book. So that's something you're going to want to look at when you're doing your diet analysis report. What is the if you're getting too much of a vitamin, well, what's the upper limit of it? Are you approaching that? Because it's okay to get more than the recommended amount of vitamins. That's okay. But you don't want to get too much. There's a line you want to walk. So there's that optimal range, and then there's the upper limit where you can get toxicity. So vitamin B6 is one you definitely want to watch out for, that upper limit. So if you don't get enough vitamin B6, again, fairly rare, because in our American diet we get a lot of it in our meat sources and our enriched grains or cereals. And but there was one scenario where it was an issue in the 1950s with babies who were fed with infant formula, and in the 50s it became a big trend to not breastfeed, to actually use baby formula to feed babies. And there was a brand, I guess, that during the sterilization process and heating process, they destroyed most of the B6 in the infant formula, and a lot of babies became B6 deficient, and it caused convulsions. And it was determined that it was because there was a lack of B6, and they were just treated with B6, and then hopefully they got better. But B6 deficiency can cause convulsions and anemia. Folate is another important B vitamin. Folate is very important in amino acid metabolism, but it's also really important in DNA metabolism. So making DNA, when cells divide, they have to replicate or copy their DNA and give a copy to the cell that the cell that's being copied. So folate is really important for that process. And in tissues in your body, cells that have to undergo a lot of replication or copying or proliferation need folate. And also during times of development, particularly fetal development, folate is very important. So it's very critical during pregnancy, particularly that very early stage of pregnancy when the cell gets fertilized and then starts rapidly dividing. That is when folate is particularly important. So some sources, food sources of folate. In food, I mentioned this earlier, in food, the form of folate is folate, and it's found in citrus fruits and in green leafy vegetables are some really good sources of folate. But in terms of supplement form, it's in a slightly different form called folic acid, which is actually more absorbable by the body. So folic acid can be found in supplements, and also any fortified foods like cereal is going to have folic acid, not folate. Both, though, help prevent deficiency disease. And there's two different deficiency sort of consequences I'm going to talk about. So there's not really a big thing there's really no folate toxicity, or not one that's well understood. But folate and B12 have very similar functions in the blood, and so getting a lot of folate can mask a B12 deficiency. So B12, we'll see, is also important in formation of red blood cells, but it also is important for protecting our nerve tissues. So if you have a lot of folate, you have healthy blood, but not necessarily healthy nerves, so it's harder to normally a B12 deficiency would be diagnosed by looking for anemia. But if you have a lot of folate, it can sort of do the job, B12's job, and prevent the anemia. So that's where taking folate supplements can be detrimental. I don't know why PowerPoint keeps auto-saving like that. It is a little annoying. So one of the consequences of folate deficiency is anemia. It's a specific type of anemia called megaloblastic anemia, because what happens is blood cells, red blood cells, come from stem cells in the bone. And these stem cells divide and they make these red blood cells, and this is normal red blood cells here. Now, if you don't have enough folate, it prevents the cells from dividing properly because they can't replicate their DNA properly. So they try to divide, they try to replicate their DNA, but they can't. So then they don't really divide. So then you end up with this cell that's not really a red blood cell, but it gets sent out into the blood anyway. And so their megaloblastic means large and immature red blood cell. So that's how folate deficiency, one of the ways you can diagnose folate deficiency is looking at the blood and looking for these large, immature red blood cells. Folate is also extremely important during pregnancy, and if you don't get enough folate in the early stages of pregnancy in particular, it can cause neural tube defects. So the neural tube is what ends up becoming the spinal cord in the brain in early fetal development. So it can cause two types of neural tube defects, or two common types of neural tube defects are spina bifida and anencephaly. So spina bifida is essentially when you get a herniation of the spinal cord. So it's actually like sticking out of the body and has to surgically be put back in, but a lot of times results in damage to the spinal cord, which can cause damage to the ability to have motor control and sensory sensations sort of below that point, so in lower body issues. Also, it can cause anencephaly, which is very sad. It's essentially, literally means without a brain. So the baby's brain doesn't fully develop, and there's actually like large chunks of brain missing. And babies who are born with anencephaly don't make it. They're either born stillborn, or they maybe last for like a week or a month. But very large chunks of brain are missing. So if you are if you are a woman of childbearing age, it is recommended that you take a folic acid supplement to make sure that if you do become pregnant, because I think 1 in 3 pregnancies in the U.S. are unplanned, unexpected pregnancies. So if you wait till you find out that you're pregnant, it's almost, not that it's too late, but it could be, depending on when you find, if you find out that you're pregnant when you're 3 months pregnant, you've already missed that folic acid window. It's really important in the first 28 days of pregnancy that you are getting enough folic acid. So it's recommended that women of childbearing age who are not on contraception, or even if you are on contraception, because we all know it doesn't necessarily work, is to make sure you're getting enough folic acid. And if you do find out you're pregnant, make sure that you're getting folic acid as well. They do have actually an upper limit for folic acid, but there's no known toxic effect. So I'm not really sure why there's an upper limit if they don't know what the toxic effect, if there is no toxicity. Vitamin B12 is the last of the B vitamins, and it functions similarly to folate in terms of blood health, but it also has the secondary function of nerve health. And what it does for our nerves is it helps to protect, to maintain these myelin sheaths. So your neurons, they have a cell body, and then they have this long tail called an axon. And when you have nerve transmissions, they originate in the cell body, and then they're transferred down the axon, which is then connected to other nerve cells. So this chain reaction sort of occurs. Now this long axon is protected by these fatty sheaths called myelin sheaths. And if you don't have enough B12, it prevents us from being able to maintain these myelin sheaths. They can become damaged and then degrade, and then the nerve cell itself can become damaged and it can degrade. So maintaining those myelin sheaths is a pretty important job that vitamin B12 has. So vitamin B12 can be found pretty much only in animal food sources naturally. Now, of course, we always, in our country, in the U.S., we fortify a lot of foods. So our grains and cereals are all fortified. So vegetarians can get B12 from eating fortified foods, but they need to make sure they're doing that, because otherwise they can't get B12 from food. And there's some sort of interesting details to how vitamin B12 is absorbed in our digestive tract. So vitamin B12, again, found in animal-based foods, which are high in protein. The B12 comes in actually bound to that protein. So in this picture, this figure from your book, this great figure, it says B12P. It's talking about the P is for protein. It's bound to this protein. So in order to get it to unbind from the protein, we have to actually unfold the protein and digest it a little bit. So hydrochloric acid produced by the stomach helps to unfold that protein and release the vitamin B12. So then vitamin B12 cannot by itself just be absorbed. It actually has to bind to the second protein called intrinsic factor, which is produced by the stomach. So this red arrow here is producing these red triangles. Those are the intrinsic factor. Okay, so as the B12 and the intrinsic factor move through the small intestine, they become bound, and then the intestinal cells can recognize it and absorb it, and then they get broken apart. So absorption of B12 requires two things to be produced by the stomach: hydrochloric acid and intrinsic factor. Okay. As you get older, your production of hydrochloric acid decreases. So you don't get as much of this going on. The B12 does not get separated from that protein very well, and therefore it can't be absorbed very well. So elderly people are the ones who are most at risk for B12 deficiency because they have low acid production in their stomach. Also, if you if you have a lot of heartburn and you take a lot of antacids or acid reducers, that can also decrease your absorption of vitamin B12 and put you at a higher risk of B12 deficiency. So if you do have B12 deficiency, it causes nerve damage and it causes anemia. And the nerve damage often starts as like a tingling feeling in the hands and feet, Also can result in cognitive functions or malfunctions, memory loss, feeling confused, etc. If you do not produce enough intrinsic factor, is another situation. So if you don't produce a lot of hydrochloric acid, it just reduces your absorption of B12. But if you have really low B12 absorption, you will have nerve damage, but you also will have pernicious anemia, which is similar to the anemia that forms with folate deficiency. But it's very dangerous. Pernicious actually means deadly. So, nerve damage and anemia are signs of B12 deficiency. So those are all the B vitamins. The last vitamin is vitamin C. And vitamin C is also called ascorbic acid. And it's an important antioxidant. So vitamin E, we said, was an important antioxidant. Vitamin C is also another important antioxidant. And then vitamin A and some phytochemicals, beta-carotene particularly, has some antioxidant functions. So vitamin C is particularly important in the lungs and helps to protect our lung tissue from oxidation. So people who smoke actually have a higher need for vitamin C because they are breathing in more pollutants, more oxidants into their lungs. So they need more antioxidant power. So the RDA for vitamin C for women is 75 milligrams a day. For men, it's 90 milligrams a day, but smokers should tack on an extra 35 milligrams a day because of their higher needs for antioxidants in the lungs. Another important function of vitamin C is that it helps us to synthesize collagen. Collagen starts with a C, vitamin C for collagen. You could think of it that way, okay? Collagen is a type of protein that's in all of our connective tissues. So it's in the skin, it's in your teeth and your gums, it's in your muscles, your bone. Okay, so if you don't produce enough collagen, if you have vitamin C deficiency, it can cause breakdown of collagen in a number of different tissues and cause a lot of different problems. So vitamin C also helps to enhance the immune system, again, through its antioxidant powers. And it has this magical ability to enhance the absorption of iron, which is very convenient because iron is a very important mineral. And so when we talked at the beginning about different things that can enhance absorption of vitamins versus inhibit the absorption of vitamins, we're going to have the same talk when we get to the chapter on minerals. And you'll see that a lot of the minerals and vitamins sort of work hand in hand. Vitamin D enhances the absorption of calcium. Vitamin C enhances the absorption of iron. So the sources of vitamin C can only be found in fresh fruits and veggies. It is sensitive to degradation over time and with heat. So the fresher it is and the less cooked it is, the more vitamin C it's going to have. Most people think, when they think of vitamin C, they think of citrus fruits and orange juice, but red peppers actually provide more vitamin C than a glass of orange juice does. So peppers are a great source of vitamin C as well, and strawberries. Okay. In the American diet, we also have a lot of other foods that are fortified with vitamin C. So vitamin C deficiency is very rare. If you ever buy applesauce or any fruit cups or 100% fruit juice or even fruit snacks, now all of these are fortified with 100% of your daily needs of vitamin C. So most Americans actually get a lot of vitamin C from processed foods even because they're fortified. So too much vitamin C, it's a water-soluble vitamin. There's really not like any significant toxicity associated with it. But if you take megadoses of it, particularly people who have a cold and they're taking vitamin C to help their cold, okay, it can cause some mild temporary side effects, including nausea, diarrhea, and nosebleeds. So if you have a cold and you're taking vitamin C supplements, watch out that you're not taking megadoses, that you're not going over that upper limit. Vitamin C deficiency, again, like I said, pretty rare in the U.S., but used to be, before they knew what vitamin C was, used to be a major issue. In fact, it was a huge issue for sailors who would go out for very long sea voyages for months at a time. And sure, they would bring fresh produce with them, but then they eat it all within a couple of weeks, and then there you go, months without getting any vitamin C in their diet. And because it's water soluble, you don't store it. So they had no stores of vitamin C. And vitamin C deficiency causes a disease called scurvy. And essentially, all of these symptoms and signs of scurvy are due to a breakdown of collagen in various body tissues. So you get bleeding gums. The gums start to break down and erode. Joints, there's a lot of bruising, a lot of bleeding, hemorrhaging into the tissues because of the breakdown of blood vessels, and weakness and fatigue, and ultimately death. It killed about half of sailors, more than half of sailors in some instances, on long overseas voyages. And then in 1740, Dr. James Lind discovered that if you give sailors rations of citrus juices, like lime juice or lemon juice, that and that they drink that throughout their voyage, then it staves off scurvy, and it actually cures scurvy. So sailors would start going out on long voyages with rations of lime juice, which led to the nickname of limeys. If you ever heard, like, old pirate movies, like the limeys, okay? Limey bastard, I don't know. It comes from that. It comes from they actually had rations of lime juice to prevent scurvy. So the last part of the chapter talks about vitamins as medicines. And this is based on some certain misconceptions that we should discuss. So the misconceptions are that because vitamin supplements can help prevent deficiency disease, because vitamins are important for, functioning, that if you don't get enough, you get a deficiency disease. So if a vitamin can treat a vitamin deficiency, maybe it can treat other things as well, which is not really necessarily good logic. The other thing is that this concept that vitamins are good for you, so you can't possibly have too much, right? That if you take a little bit of a good thing, it's a little good for you, and a lot of a good thing will be a lot good for you, but that's not necessarily the case. Remember, we always say too much of a good thing is never a good thing. So those are some misconceptions that have led people to believe that different diseases or things can be treated with vitamins. And in some cases, very specific but rare cases, there are some diseases that we'll talk about that can be helped by vitamin supplements, by certain large doses of vitamins. But for the most part, vitamins only treat vitamin deficiencies. So a lot of different supplements will come with health claims that are based on the role of that vitamin. So here's an example. Vitamin A, very important for eye health and for vision. So if you don't get enough vitamin A, you can have night blindness, you can have total blindness. So taking vitamin A is going to be important for maintaining good vision. Taking excess amount of vitamin A doesn't mean that you're going to have super vision, doesn't mean you're going to be able to have X-ray vision if you take large amounts of vitamin A. In fact, if you take large amounts of vitamin A, it actually will hurt your vision. It actually causes damage to the eyes. So you have to be careful about health claims, because a health claim can do that. It can say something like, oh, vitamin A, take vitamin A to improve your eyesight. It's only going to improve your eyesight if you're not getting enough vitamin A and you have deficiencies in your eyesight because of vitamin A deficiency. So health claims are based on true functions of a vitamin, but doesn't necessarily mean that it will improve your health only if you are missing that vitamin. If that makes any sense. So some different vitamins that are used as medicines or treatments. Niacin is one that I already indicated, where it's been shown that large doses, I probably should change this, I don't think it's megadoses. Megadoses are 10 times the recommended amount. I think just large doses are used under medical supervision, of course, because there are some toxicity signs of too much niacin. And they can be used to reduce LDL levels, bad cholesterol levels, and help to prevent heart disease. So there are side effects of that. Flushing and nausea can be side effects of too much niacin, and also if you, over time, you can accumulate liver damage. So again, these types of large doses are usually given under medical supervision and are not recommended that people try on their own. Vitamin B6 has been marketed for a number of different things to cure anything from PMS to hangovers to carpal tunnel syndrome. And there's no scientific evidence that supports any of those claims. And vitamin B6, remember, is one of the B vitamins. Niacin and vitamin B6 are the two that are particularly prone to toxicity. Even though they're water soluble, they can be toxic. And vitamin B6 can result in nerve damage. So if you have taken B6 before for any of these reasons, definitely be careful about that. A combination of a couple of B vitamins, folic acid, B6, and B12, it's been thought that they can, it's been shown that they can reduce the levels of homocysteine in the blood. B6, remember, is particularly important for breaking down homocysteine and breaking down amino acids. It's the protein B vitamin. And so it can lower blood levels of homocysteine. And if you remember, homocysteine was that toxic amino acid that increases your risk for cardiovascular disease. So it's interesting, it can reduce homocysteine levels, but it doesn't reduce the risk for cardiovascular disease or Alzheimer's, another one that's associated with high homocysteine levels. So it kind of calls into question the role of homocysteine on these diseases, but so it's interesting. It can reduce the amino acid, but it doesn't seem to reduce the disease at all. So kind of useless again. Vitamin C is a very popular one. The concept, the idea that vitamin C helps with the common cold, that it can either prevent the common cold or treat the common cold. And there's no evidence that suggests that vitamin C can prevent a cold. There is some evidence that suggests that vitamin C supplements can decrease the duration of symptoms, so it can cut your cold symptoms down by a day or two. But whether or not that's a real effect of the vitamin C or an effect of you taking better care of yourself is unclear. But surely if the vitamin C supplements make you feel better, they're not harmful. There's no toxicity. If you really overdo it, you might have some nausea or stomach cramping, but there's no sort of dangerous side effect of too much vitamin C. The antioxidant vitamins, vitamins C, E, and A, okay, there's research looking into whether those taking high doses of those antioxidants will help prevent cancer, cardiovascular disease, Alzheimer's. So all of those things we talked about in the beginning when we talked about free radical damage and how free radical damage helps contribute to aging, to cancer, to cardiovascular disease. And so the idea is that the more antioxidants you have, maybe the more protection you have against those free radicals and those diseases. But no scientific, also, I guess the other thing is that diets that are high in foods with a lot of antioxidants, so diets that are high in plant foods, do correlate with less risk of heart disease and less risk of cancer. So scientists hypothesize that maybe it's the antioxidants in those fresh foods, in those plants, that prevent cancer and Alzheimer's and cardiovascular disease. So they've done studies where they give people, they have two groups, and one takes antioxidant supplements and one does not. And there's no effect. Taking it in supplement form, there's no effect. There is some toxicity risk, particularly with vitamin E and particularly with vitamin E. Vitamin A is usually given in the form of beta-carotene so that there is no toxicity risk. And nausea from vitamin C can be an issue as well. So they did not support that there's any effect of those antioxidants for these diseases, cardiovascular disease, Alzheimer's, or cancer. There is one disease called macular degeneration, which occurs in the eyes, and they have had some evidence that taking these antioxidant supplements may slow the progression of macular degeneration, but it doesn't prevent it. It won't prevent macular degeneration, but if you have macular degeneration, you can slow it down. Essentially, macular degeneration is when the middle of your retina starts to degrade, and so you can't see, the middle of your vision field is very fuzzy, but everything around it is clear, but the middle of your field of vision is fuzzy. And then that little spot in the middle can grow and grow and grow as the macular degeneration continues. So the moral of the story of this whole vitamins as medicine thing is that taking vitamins really does not replace the need to eat a healthy diet. Vitamins can be used as sort of an insurance policy to make sure that you're getting the adequate amounts, but you shouldn't depend on vitamins from supplements because they don't necessarily do the same job as your vitamins from food. So I like this statement here. The benefits of vitamin supplements is uncertain, but the benefits of a diet that's high in fruits and vegetables and naturally high in vitamins is very clear. And very clear in terms of its ability to reduce your risk for cardiovascular disease, reduce your risk for cancer. And the chapter highlight talks a bit, and quite in depth actually, about diet and cancer. And I just want to talk about it sort of very briefly, what cancer is and the types of diets that prevent it. So cancer essentially is when a cell that's undergoing division undergoes a mutation, and that mutation causes it to divide uncontrollably. Okay? So you get this rapid division of the cells, and they keep dividing and dividing. And then that would be a tumor, a cancer that hopefully would be caught by a doctor and removed. The danger is if the cancer progresses and moves, the cancer cells actually get into the blood and then can move to other tissues and grow in other tissues and other places. Okay? And then you have tumors all over your body. So this is what we call a metastatic cancer, when it can travel. So cancer can originate in different tissues. Different types of cancer grow faster, are more aggressive than other types of cancer, are more prone to spreading than other types. So there's a whole bunch of different types of cancer. Essentially, they are all caused by cells that proliferate uncontrollably and grow out of control. And usually that out of control growth is stimulated by a mutation by a substance called a carcinogen, which is just any substance that causes cancer. And there's lots of different carcinogens in the environment. There's environmental carcinogens, pollutants that we breathe in. And just because you get exposed to a carcinogen doesn't necessarily mean that you develop cancer, because your body actually has, your immune system actually has cells that patrol and kill cancer cells. So you do have a bit of an immune system to protect yourself from cancer, but sometimes your immune cells miss a cancer cell and it has the ability to grow and take root. So other factors besides exposure to carcinogens affect our risk for cancer. Your genetics, some people are just genetically predisposed. Lifestyle, how many different types of pollutants you're exposed to, your overall health, and your diet, exercise regimen, all those things. So in terms of diet, antioxidants and phytochemicals are thought to be the biggest sort of contributors to protecting us from cancer. particularly those that are naturally come from plant sources. So the only diet really that's been shown to help reduce your risk of cancer is diets that are high in plants and fruits and vegetables, not necessarily any kind of supplements. So any vitamin C or antioxidant or phytochemical supplements have not shown to give you the same protection. But it's thought that potentially it's those antioxidants in the foods that help to protect you from cancer. But it also, the book talks about different carcinogens that are formed by meat. When you cook meat, you change the molecular structure, and there's some components of cooked meat that have been shown in the laboratory to act as carcinogens. So the other idea is that it's not that the plant foods protect us from cancer, it's that the meats actually cause cancer. It's the other hypothesis. So neither one can really be proven, but the trend, the general sort of moral of the story, we can't really draw any conclusions from it, is that diets that are lower in meat and higher in plants are lower in cancer. Whether it's because the meat causes cancer or the plants prevent cancer, it's unclear. But that is sort of the trend. And that's essentially what the end of the chapter spends a lot of time explaining and talking about the formation of cancer. So that is chapter 8. I think it did take about 2 hours. And if you have any questions about the chapter or the lecture or the homework, please do email me or call me. And that's all. Thanks for watching. Bye.